You'll notice that we have 4 problems given in this lesson, because this is the culmination of all the lessons. The ability to add and subtract fractions with common denominators as well as unlike denominators. So you've noticed that I've taken my my image out of the picture, so those of you who are copying will have an unobstructed view. What I'm going to do is to break this up, but because it's all scrunched here, I'll break these things up into individual pieces, and we'll tackle these accordingly. The first problem is a subtraction with common denominators. Well, the common denominator is a good thing. However, we need to take 5/7 away from 2/7, and there aren't enough sevenths. In order for us to work this problem, we're going to need to borrow, and we're going to go next to the fraction and borrow 1 from our number. So instead of 14, we'll have 13. And if you recall, that 1 slides over as a whole number. Let me just rewrite this. This will become now 1 plus 1 and 2/7. And the 1 and 2/7 is a mixed number right now. However, we're going to quickly make it into an improper fraction. So 7 times 1 is 7, plus 2 is 9, and we get 9/7. Now, we are still taking 5/7. It's been waiting patiently down below until we're able to make this top fraction into something more workable. We're going to take 5/7, subtract 9, and subtract it from 9/7, and we get 4/7, and we have no whole numbers from 13, leaves us 13. So my final answer should be 13 and 4/7. Let's go up and see. 13 and 4/7 would be answer D, and that is problem number 1. Now let me switch to the next sheet, and problem number 2 is an addition problem, and we have mixed numbers with different denominators. Well, as always, we need common denominators. We can quickly see that the 8 is only made up of 2's, and the 3 is just itself. So our common denominator would be 3 2's and 1 3. The 8 is missing that 3, so let's multiply the denominator by 3, and if I do the denominator by 3, I'll also multiply the top by 3. And as for this other fraction, if the denominator is a 3, it's missing 3 2's, and 2 times 2 times 2 is 8, and we'll multiply it to the bottom as well as the top. Now recall, each of these fractions will still be the same value, they'll just look a little different. Now this is 5 and 3/24 when we get done multiplying, and our next number will become 3 and 16. 8 times 2 is 16/24. Well, now that we have 24ths, we have the ability to add common denominators. So 3 of these and 16 of these makes 19 of these, 19/24, and 5 plus 3 is 8. So our answer should be this, unless of course this denominator is reducible, but 19 is a prime number and is only divisible by 19, but 24 is not. So our final answer should be 8 and 19/24. Let's see what that looks like. 8 and 19/24 is answer A. As for our next problem, let's go back to our other page. We have 20 and 9/10 plus 2/18. Well, we have a different denominator here than here. So we'll break this up into its prime factors. 2 times 5. 18 is 2 times 9, which is 3 times 3. Our common denominator, the most 2's, well, it's tied with 1. The most 3's is here, and we have 2 of them. And the most 5's is here, and we get 1 of them. 2 times 5 is 10. 3 times 3 is 9. And when we multiply 10 times 9, our new common denominator, our lowest common denominator, will be 90. Well, what I'd like to do is build 10 up into 90. We can all see that a 9 is is called for. But remember, 10 is 2 times 5, and when we look at the pieces that make up 90, it's missing 2 3's, and 3 times 3 is 9. So try to do it this way. So if I multiply the bottom by 9, I have to do the same to the top, so that I multiply by a fraction that equals 1. As for the 18, it's made up of 2 times 3 times 3. Not so easy to look at 18 and 90 and see what's missing. But if you look at the pieces that make up 18 and the pieces that make up 90, we're looking for 1 2, 2 3's, and 1 5. And that's the missing link right here. So that 5, it's a lot easier to see what's missing than to divide 18 into 90. So what I'm going to do is multiply the top and the bottom by 5. The fraction that we're left with now, the numbers, will become 20 and 81 90ths and plus 10 90ths. Now, if I put the 10 90ths down below, just to make it a little bit easier, we can add these together, and 10 90ths plus 81 90ths make 91 90ths, and then the 20 is out in front. Again, no whole number. If there was a whole number, it wouldn't be a tough thing to add. But recall that we cannot have an improper fraction and a mixed number. So the 91 90ths, I think you can see very easily, when you divide 90 into 91, it goes once with a remainder of 1, which we can make into 1 90th. So it's 20 plus 1 and 1 90th, which is 21 and 1 90th. And let's see where that is on our answer. And 21 and 1 90th. So our answer to that is B. On the very last problem, we need to subtract and we need to have a common denominator. So as you can see, let's break this up. 15 is 3 times 5 and 10 is 2 times 5. My common denominator will be made up of the most 2's, the most 3's, and the most 5's, and it's a tie. So this number, 2 times 5 is 10, times 3 makes 30. Pretty easy to see how we can make these into 30, but again, 3 times 5 is 15, and we're missing a 2. A lot easier to see the what's missing method. And 10 is 2 times 5. Here's 2 and 5. It's missing a 3, and we'll multiply top and bottom by 3. Now this number will become 17 and 2 30ths. This one is, we're subtracting 9 and 9 30ths. Okay, we run into a little problem here. 17 and 9, these are easy, but we need to take 9 30ths away from the number 2 30ths. And there isn't enough 30ths. So what we'll need to do is we'll borrow 1 from the 7, and that will come here, and this will be 1 and 2 30ths. So our problem is really 16 is the whole number, and 30 times 1 is 30, plus 2 is 32 30ths, and from that we want to subtract 9 and 9 30ths. Well, 9 from 32 is 23 30ths, and 9 from 16 is 7. Now, is this fraction reducible? I love prime numbers because 23 is that, and the only number it will be divisible by is itself. 30 is not divisible by 23, so that should be our final answer. 7 and 23 30ths. Let's check. 7 and 23 30ths is also answer B, and that is the culmination of our adding and subtracting fractions.